One of the most important test is data normality. What is data normality? Brother Shahriar, can you explain, brother?
Actually, we can do the normality test for a data set which we conclude that either it can follow the normal bell-shaped curve or not. Basically, we can apply it for a parameter. We can say that either data is parametric or not parametric. If data is parametric, it will show the rules of normality. It will follow the bell-shaped curve, and we can subsequently apply the specific test which follow the parametric test.
MashaAllah. Thank you very much,
Me,
brother.
I will further add it that if data follows normality, we can say that our 65% of the data lie within the plus minus 1 standard deviation of the mean, and our 95% of the data lie within the plus minus 2 standard deviation of the mean, and our 97.7% of the data lie within the plus minus 3 standard deviation of the mean. So it basically tells us that our population is normally distributed or abnormally distributed.
You got if our data is normally distributed, it will show the in histogram. It will show the bell shaped, right? And why it is necessary? The data should be normal, brother Shahriar.
Sir, when the data shows, for example, we can compute the age of individuals, and our data shows much dispersion or kurtosis or skewness. So we can say that data is not properly collected, or our data shows much skewness, so we cannot apply the standard statistical test. For example, we can't apply it univariate. For example, we can't
Non-parametric
apply.
test, right?
Exactly, we can go for non-parametric tests like Wilcoxon, like Mann-Whitney, like Screwball test.
Yeah, mashallah. Thank you very much. Actually, there are two kinds of data normality. One is univariate data normality, another is multivariate data normality. So, univariate data normality can be tested through the skewness and kurtosis. Either your data is skewed or kurtoed towards any side, or and your data is multivariate normal. The multivariate normality can be checked by the Mardia test. However, the SPSS do not support the multivariate data normality. We have another software in internet that we can use their software for multivariate data normality. Today we will learn how to do the skewness and kurtosis test to check our data is normally distributed or not. Okay, please open the data set 5, data set for data normality by skewness and kurtosis. The 5th number, please open this one. Okay, everybody opened it?
Yes, sir.
Okay, mashallah.
Open.
Okay. Now what will we do? We will go to the analyze, everybody, and if you just follow my instruction here, you will get. Okay, later on I shall explain, but here you will if you go to analyze, if you follow this one and all of this, then you will find the same thing. That, but here just follow me. Go to analyze, go to descriptive, then go to descriptive, then take all the items to the right side and go to the option. In the option you will find here the kurtosis, skewness and kurtosis. Okay, we need these two values, very important.
Doctor, sorry, doctor, can you repeat the process again?
Okay, yes, why not? Sister, did you open your file? Sister, the file number 5, SPSS file
Yes,
number 5.
I understand.
Okay, please go to analyze, go to descriptive statistics and go to descriptive, the second option here, and select all these items in our data set. Just press click on OS 1 and press the shift button and click the last one, all will be selected together. Then take it to the right side. Are you following, sister?
Yes, Dr. King.
Okay, then go to the options, then select the kurtosis and skewness. Okay, then continue,
Okay.
then okay. Okay, so this is the result that we get. Suppose for the OS 1, does this value, the skewness, the minimum 1, maximum 5, mean value this one, standard deviation is this, and brother Shahriar, what this 1.143, what does it mean? The standard deviation 1.143 here. Brother Shahriar, are you there? Dr. Humaira?
Yes, Doctor, did you call
Yes,
me?
brother Shahriar. In this descriptive statistics, we have the result of standard deviation of the mean. Mean is 3.56, and standard deviation of the statistics, the value given here 1.143. Here,
Well,
what does this standard deviation means here?
well, doctor, I got your message. I will explain it little
please.
elaborately.
Okay, please.
We actually, for fringe 7 variable, we got the mean value of 3.56 and a standard deviation of 1.143. It's mean that our data set actually 2.1 to 4.6. Our overall data is between we can minus 1.14 from 3.56 and add 1.143 to 3.56. So it's mean okay, our whole set data minus 1.14. If we can minus 1.14 from 3.56, so we can lead towards the left side. And if we can add 1.14 standard deviation with 3.56 mean, so it will go towards the positive side. Let's explain it from another angle. If we make bell-shaped curve and draw a line in a central, so our central value will be a 3.56.
Yeah.
And for both our left side and for our right side, for our left side, the value will be around about
1.143.
2.1, and for our right side, the value will be for round about 4.1 or 4.5. It actually means that.
4.4. Okay.
So can I explain in another way?
Yes, please. We want to know more about it.
Okay, sir.
Okay.
And we have the standard deviation,
Yeah.
and we have the bell shape, which means the numbers that will fall within the standard deviation,
Okay.
which means the bell shape are the 3.46 plus or minus 1.143.
Oh, yes. The standard deviation plus minus 1.143. Data is dispersed in left
Yes.
side minus and right side
And
plus. In left
plus.
side minus
Why the
1.143 and right side 1.143.
1.143. Why the middle number? The middle of the bell shape is the mean. That is
Yes, the bell
3.56.
shape. The peak is the mean value. Yes, bell shaped. Yes. Okay.
Thank
Now
you, sir.
the skewness and kurtosis.
I have a question.
Yes, please.
Okay. So I want to, although I'm not a statistician, they are giving the better explanation about the mean and standard deviation. I can say that mean value is the middle value,
Yeah.
and in case of standard deviation, we can either move right or left, either positive or negative. So exactly the mean would be the average or middle value. And
Exactly,
I have a
sister.
question regarding skewness and kurtosis. So, is it mandatory to go for both skewness and kurtosis tests
Yeah, both
or
is
not?
required. Yes, both is required. Both
Okay,
values
although
is
there is
required.
a difference between the values between skewness and kurtosis.
Yes,
I
Uh,
will add.
yes,
I want
yes,
to add
yes.
something over it.
okay,
I want to answer it. Skewness is basically a measure of symmetry. That our left side is symmetrical to our right side, and in an easy way, we can say that our data is precise or not precise. The lack of symmetry of the normal distribution. Actually, symmetry tell us the lack of normal distribution or not. While kurtosis is basically a measure of a peakness of a distribution.
Thickness.
So when our peakness is not normally distributed or our symmetry is disturbed, so we can go for the non-parametric test.
Yeah. In the case of skewness, it is positively skewed or negatively skewed means it is in left side, towards the left side. It is means in negative more data is less than 3. If we are using the 5 Likert scale data, so more data is in left. More respondents they have selected 1 and 2 like this. If it is the positively skewed, then more data is more data is been selected 4 and 5, that we easily can understand from the skewness. And the kurtosis is just it is how much the picked, right, brother Shahriar? That is, it is very high or low like that.
Exactly, it's also indicate that the graph, the peakness of basically a normal distribution curve. If
Yeah.
the peakness is again disturbed, we can't apply the parametric test over it. And if we can apply the parametric test over it, our result will be falsely described.
Mashallah, mashallah, brother Shahriar.
So can I add something
Yes,
too?
yes, brother
okay.
Frank.
In case
Frank.
of skewness or kurtosis, ideally, I think it should be zero, near to
Since
No,
zero.
no, no,
the
no. I'm
non-test,
giving you the
But
rule of
although it
thumb.
is not possible, I guess.
Yes, sister, the rule of thumb for the skewness is plus minus 2. And kurtosis, some authors says it should be plus minus 1, but according to higher, it should be within plus minus 2. And kurtosis also, according to higher, it is the rule of thumb. The result, if the kurtosis value within the plus minus 2, your data is normally distributed in the case of kurtosis. But according to Palanth, he recommended that if the kurtosis value within the plus minus 7, it is your data is normally distributed. In that case, you can go for the parametric test.
Doctor, I want to add something
Okay,
more.
please, please.
As a general rule of thumb, here in Pakistan, we use a general rule of thumb that if skewness is less than -1 or greater than 1, we conclude that the distribution is highly skewed. And if skewness is between -1 and
Plus 1.
-0.5 or
Okay.
between 0.5 and 1, the distribution is basically moderately skewed. And if skewness is between -0.5 and plus 0.5, the distribution is approximately symmetrical. So on the basis of obtained value of our SPSS analysis, we can say that our data is highly skewed, moderately skewed, or approximately
Okay.
symmetric.
Symmetric. You got the point,
So,
sister?
what is your opinion about the performance one here? If I can see, the skewness value is minus 1.057, although the kurtosis value is 0.118. So either we will go for a parametric test or for a non-parametric test for sure.
Okay, that's why I told you different author recommended different different rule of thumb, but according to Higher, which is well established and well recommended by different scholars, that Higher, according to Higher, he recommended plus minus 2. So if it is your skewness value in between plus minus 2, then it is normally distributed. So you don't have any issue, any normality issue. Okay, sister. If it is more than 2, in that case, we can look at the our outliers. Sometimes outliers influence our data. That's why if we delete sometimes it can be resolved by deleting some observations, those who are outlier. And if after deleting the outliers, if still data not become normal, then we go for non-parametric test. Okay, sister.
Yes. Okay. Thank you so much.
Okay, brother Frank.
Okay, sir, please, can we come back to the standard deviation? I didn't understand how we got it, the result.
Your question not clear, brother.
Okay, sir. I didn't understand how we got the deviation statistic result.
Did you got his question, brother? Get his question, brother Shahriar?
No, sir, I didn't got as well.
He asked, I got the question. He asked
Is that
how we got the
how do we
standard
get standard
deviation.
deviation?
Okay.
It was selected. It's
No, it comes automatically. The result comes automatically. Standard deviation. We don't select any standard deviation. It comes automatically. Yes, standard deviation. Yes, we select it, and this result is very necessary. Standard deviation is very important result that we need to put here. The options in some cases the standard deviation result comes automatically. Okay, brother Frank.
Sir,
Yeah.
I have a question. Though I am no one from statistics, I have no idea about this. So maybe my question may inappropriate. Pardon for this. To test the normality, we should count the standard error, like you told, between minus 2 to 2. So we should count the standard error.
We don't use the count standard error over here. We count
we should
the standard
consider
deviation.
which one. You told between minus 2 to
that
plus
is
2.
the skewness and kurtosis values. It should be within this range. If it is above this range, then we will consider the data not normally distributed.
Okay, but I can see there are two column like statistic and standard error.
Yes. You maybe you are asking from here. Yeah, right. The skewness and kurtosis, right?
Yeah. I was from this.
Okay. The skewness value. Oh, yes, standard error, brother.
Yeah.
Thank you, sister.
Yes.
What is standard error means here, brother Shahriar? Brother Kamal, we will come back again to you.
Sir, it will be difficult to say, or ma'am can easily get the concept from definition, but I will tell the definition of the standard error, or simplify it in a simple way, that actually the standard error of the mean, or we say standard error, we can calculate it from our different samples. It basically indicates how different the population mean is likely to be from a sample mean. For example, our population is basically 20,000 disease patient, and first we can take only 1,000 patient out of 20,000 patients. So our 1,000 patient is one sampling frame. Then and some another time we can take another bunch from the population of 1,000 persons. So we can take 5 to different sampling frame from that particular population. So standard error basically tell us that either if in some other times we can take the population, and is there is certain standard error between the different population or obtained samples or not. I think so. You can't get the message, but you can read it by yourself.
Yes.
So you can easily understand the standard error.
Okay. I am simplifying. I am helping brother Shahriar so that our sister can understand it. What happened? Sometimes we asked to measure any variable. Suppose in our last example, for suppose we asked any person to measure, why don't you allow your wife to go to the to do the job. Okay, this is the question, and you have given certain options, 4 or 5 options there, or and you have you don't allow because you want number 1, you want your wife will taking care of your children. Secondly, from the religious point of view, you don't want her to go outside mixing with others. You don't in this, from this perspective, you don't allow. So you have given certain options. So other than you have selected these options there, other than these, maybe your respondents might have different other reasons for which he is not allowing his wife to go to the job. So that that is the researcher, he did not consider that option for these respondents. These options not available here. So that's why since we are not considering those factors in our study, in our and that is not put as options to the respondents, so we consider that that is the standard error of our question, of our variable. You got the point? Which is not considered for measuring a particular variable. Which factors?
Sir, I want to
Yes, sir, I got it. But my question was also that in testing the normality, data normality, we should consider this standard error, right?
No.
To check.
No, we should not look at the standard error. We have to look at the statistic, the value
Oh,
of the
okay,
statistic.
okay.
Here,
Yeah.
Sir,
if the value of statistic, the Kurtosis value of statistics, and statistic for skewness, if these values is within the plus minus 2, then you will consider it is normally distributed, and if it is above that, then it is not normally distributed, it is non-parametric. So yes, please.
Sir, I want to add something more.
Yes,
Basically, standard error tell us how much the sample mean would vary if you were to repeat a study using new samples from within a single population. For example, if you obtain after applying the standard error and the value obtained is 0.8 to 0.9, it's mean that your sampling frame is good and it is acceptable reliability for any assessment. So simply we can say that for our sample reliability, we can apply the option of standard error.
actually statistical point of view and statistical explanation is very difficult to understand for non-statistician people like us. Thank you, brother Shahriar. We are learning a lot of technical things from the statistical point of view. Thank you very much. Actually, those who are in business, in engineering and medical, it is very difficult to go in depth in statistics. So for our for our uses and for our own requirements, we need to know some basic things. If we go in depth, then we will be out of our from our track to we have to go specialized in statistics. It's very difficult. So however, the basic things need to be known to everyone. If you are if you want to fix yourself in research, especially in social science research, as nowadays in other research as well, because in medical science also they are using the survey questionnaire technique, as well as the engineers also they are doing survey research. So everybody knows to know the basic things. Okay, we should not spend much time over here, okay, because we have a long way to go.
Can you hear me, sir?
Who is this? Okay, yes, please.
This is Janzib.
Okay.
Kindly, sir, repeat this activity again, sir. This Skewness Kurtosis, how to perform this one?
Okay. Thank you very much, brother.
Because I am facing some problems
Okay,
here.
okay, brother. So you have to go to the analyze, go to the
Yes.
descriptives, and go to the descriptives. And
Yes,
suppose you have to take all the
Here.
items.
Here I have problems, sir. I don't know. Let me share the picture.
Okay, please share your screen. Please.
Okay, sir. Okay. In the WhatsApp group I am sharing. I don't know from where I have this problem.
You can share your screen, brother.
Separate. I am using mobile, and for SPSS I am using my laptop.
Okay, brother.
I shared in the group, sir.
Okay.
This is the problem, sir, I am facing. I don't know.
It's okay. Okay. Just a minute. Your name, brother? Jehanjeb.
My name is Janzeb. Basically, I am from Pakistan and currently working as a lecturer in Afghanistan.
MashaAllah. Which university? Helmand?
Rana University, Kabul.
Okay, brother. Free joys. And freeze and joys.
This is automatically coming. I don't.
No, brother.
I use the same file.
No. You have to open another file, brother. You have to open this file, 5 number. It is opened in this one. You have to open this one.
Oh, file number
5.
This one is file number 5, sir. Data set for data normality by Skewness and Kurtosis.
Yes,
this
brother.
is the file. Okay.
Here in your case, it is the data is showing wrongly, because fringe 7 and then showing ways 1. That's the issue, I think.
Yes, sir. The same file I used so many times. I used this one, but I'm
okay. However, I'm going to see your issue in variable view. See, maybe you have changed here. See, in variable view here, fringe 7 here. I think just what will you do? You just copy this one. Just copy and paste here in variable here. Then I think there will not be any issue then.
We can't see your screen.
Huh? Yes, sorry.
We can't see your screen.
Okay. Brother, what will you do?
Okay.
Please copy this one.
Uh-huh.
Okay.
Left.
Then paste over here. You have wrongly you did some wrong thing maybe. That's it. Then save it. Then you go to the analyze and descriptive again. Then it will come. No problem, inshallah.
Okay. Okay.
Okay. Now we shall do the once if you have sometimes if your data not normally distributed, if we delete the some observations who are outliers, maybe sometimes our data become normal. So how to calculate the univariate outliers? So we will know a test of outliers. Oh, what is outliers? Who can explain better other than brother Shahriar? What is outliers?